Good evening, pre-algebra. Mr. Lawrence here with your flipped lesson. This is part 2 of the review. Remember, part 1 of the review was on December 9th. You can go back and watch that again if you need to. This part will cover a couple ugly or what I called strange equations and inequalities, and we'll do a I can't think of what it's called, a perimeter problem, and we'll do a couple translating problems, but I'll make it nice and quick. Oh no, I'm not in write mode. Okay, so let's say we had a problem like this, 2x minus 5 over 3, and that was less than 12. Before I can solve an equation like this, I need to get rid of this division. Right here, this 3 is messing things up. It's attached to the 2x and the 5. I know this is review, but that's what we're doing, reviewing for a test. To undo division, I will multiply each side by 3. Now, some of you are using the Great Wall, so let me put a Great Wall in here. All right. Those will cancel, leaving me 2x minus 5, and that'll be less than 36. Okay. I will then listen to Saddam. Don't forget to listen to Saddam. You gotta listen to Saddam. Bad things happen when you don't remember to listen to Saddam. So I will add 5 to each side. Why? Because Saddam told me to. And then I will have 2x, which is less than 41. All right, now to get x alone, I will divide each side by 2. And I will get x is less than 20 and 5/10, or 20 and a half. Because it's an inequality, I will graph my solution on a number line. Shoop, shoop. Let me see here. 20.5. It's an open circle. Now, some of you make a mistake here. You can't remember which way to shade. Well, I'm going to write a blank, a less than, and 20.5. Go ahead and fill in a value for x that makes this true. Well, let's see. I need a number less than, let's see, is 30? No, 30 is not less than 20.5, so that's not the number I want to put in there. How about 10? Yeah, 10 would work. 10 is less than 20.5. Where would 10 be on the number line? I think it would be to the left of 20.5, so I will shade towards 10. There we go. All right, remember when you have a problem that looks like this, that's a distribution problem. I need to distribute first, and once I distribute, it won't be so strange. When I distribute, I multiply. Negative 3 times x, negative 3x. Negative 3 times negative 5, positive 15. Remember, that was negative 3 times negative 5, so I get positive 15, greater than or equal to 10. If you want my Great Wall in there, for those of you that need it, no problem. There it is. All right. Now I listen to Saddam, who tells me to undo the addition first. Nick Miller can tell you why I didn't add 3 to both sides. I'll bet Nick would say, well, that negative 3 is attached to x by multiplication, not by subtraction. That's why we don't get rid of it first. So I bring down a negative 3x, greater than or equal to negative 5. And now I'm going to divide by negative 3. Danger, danger, Will Robinson. Woot, woot, woot. Alarm should be going off in your head, other than my alarms. I've got x less than or equal to. That's right. This inequality had to change direction because I divided by a negative. I can put 5/3 down. I can simplify 5/3 to 1 2/3 if I want. That would probably be a better idea for my graph. Now let me see here. Draw my number line. We got a 1 2/3. I'm going to have a closed point because it's equal to. Again, I can't decide which way to shade. Blank, less than or equal to 1 2/3. Well, let's see here. Let's put a number in. I'll bet you 0 is smaller than 1 2/3. 0 would be over here. I will shade towards the 0. All right. Oh, my shading is out of control. There you go. Okay, let's move on to a perimeter type problem. Let's say you have a rectangle that looks just like this, and you are told that this side is 2x plus 1, and this side is 3x minus 2. All right, and you're also told that the perimeter of this shape is, one second, the perimeter is going to equal 28 centimeters. Okay, the first thing that might be a really good idea to do is to label the other two sides, 3x minus 2 and 2x plus 1. All right, now I'm going to take a walk around my shape. Shoop, 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 shoop. All right, let's see, how far did I walk? Well, I walked 3x minus 2, and then I walked another 2x plus 1. Oh, you're probably not going to like it that way. Tell you what, I'll add up my x's first. When I go this way, I've walked 3 x's. Now I've walked 2 more x's, so I'm up to 5 x's. Now I'm add 3 more x's, I'm up to 8 x's. And then I go here, and I've gone another 2 x's, so I'm up to 10x. Now I'll add up my non-x numbers. I'm at negative 2. Negative 2 plus 1 is negative 1. Negative 1 and negative 2 is negative 3. Negative 3 and positive 1 is negative 2. So, oh, I lost my x there, didn't I? That's not good. 10x minus 2 equals 28. Now I'll just listen to Saddam. There he is again. Saddam telling me what to do. And I'll add 2 to each side, giving me 10x equal to 30. And then I will divide by 10 on each side and discover that x equals 3. Now I'm not done with the problem. I've got to take this 3 here and stick it in for x. So for example, this side will become 2 times 3 plus 1. Well, I think that'll be 7 centimeters. This side here will become 3 times 3 minus 2. Well, 3 times 3 is 9. 9 minus 2 is 7 centimeters. What a coinkydink. I actually end up with a square. How do I know it's a square? Because both sides are 7 centimeters long. All right, I was told it was a rectangle, which is true because a square is a very special type of rectangle. All right, let's try a couple problems here, like, let me type them in for you. Okay, 5 less than a number doubled is no more than 35. Where am I going to start? Somebody's yelling out, 5, 5. Thank you for playing. We are not going to start with the 5. We're going to start with the number. Curvin can tell you what the number is. The number is n, or x, or h, or k, anything but o. Any variable you want except for o. So the number is n. Now, what do I need to do that number? I need to double it. I need to double it. Well, if n is the number, then doubling n would give me 2n, or some of you like to write n times 2. That's perfectly acceptable. Now I need 5 less than this, and many of you get this wrong. Let's play the 5 less game. I will write down a number, say like 13. Get me 5 less. I think that's going to be 8. How did you get there? Yeah, minus 5. Okay, let's try another one. Let's try 20. What's 5 less than that? Oh, it's 15. How did you get there? Ha! Minus 5. So 5 less must be minus 5. Not 5 minus, minus 5. So I shall subtract 5 here. Now it says it's no more than 35. Could this 2n minus 5 be 35? It could. But it can't be more than 35. Could it be less than 35? It can. It could be 34. So it'll be less than or equal to. Now it's time to listen to Saddam. I'll add 5 to each side. Put my great wall in for you. All right, we'll get 40. We'll get that. We'll get 2n. And I will divide by 2 on each side. n will be less than or equal to 20. Yeah, 5 less than a number doubled is no more than 35. So if I double 20, I get 40. I subtract 5 from that, I get 35. So it works for 20 and any number smaller. All right, folks, that's your review. You can go back and watch uh, the one from the ninth. You can watch this one, and you've got a review sheet to study. Come on, guys, give me your A games tomorrow. I want good grades tomorrow. You guys are all capable. Show me what you can do. All right, Mr. Lawrence signing out.